Hello, welcome to this lesson of our study of mathematics or our journey through mathematics. Okay, so in this lesson, what we are going to do is we are going to go through differentiation. Okay, so solving polynomial differential problems and solving differentiation that involves polynomial functions, and then we'll look at an application where we apply the idea of differentiation in gradients. Okay, on a curve. So the first question is saying differentiate the function f of x equals this here 2s cubed, okay, minus root of x plus the fraction s squared plus 2x as numerator over s squared with x greater than 0. Right. So with this, what we can do here is that to differentiate polynomial function, let me rewrite it back. F of s equals 2s cubed minus square root of x plus s squared plus 2x over s squared, then with the condition that x is equal to or s is greater than 0. So I can go ahead and simplify this term here because it looks like we can simplify some terms. Okay, so this is the same as 2s cubed minus square root of x, then plus, once we have some expression at the numerator, I can separate them and do it like this: s squared then plus 2x over s squared. Okay, now this can again be simplified into 2s cubed minus square root of s is x to the half, then plus 1, then plus 2 over x. Okay, now this is it. So you are supposed to differentiate this. So to differentiate a polynomial function, we call it the f dx, or you can say f prime of x, and this is equal to, when you don't differentiate polynomial functions with separate terms like this. Okay, so along the line we'll know how to differentiate some basic things. So with separate terms like this, what you do is you pick each term. So you just pick the power of the x, you multiply to the front of x here. Okay, so that will give us 6s. Then you subtract 1 from the power. Okay, so it becomes 6s squared, right? So that's the differential of this first term. And you differentiate this, so you multiply the power of x in front and you have half right of x, then you subtract 1 from the power and that becomes minus half. Okay, then with this we assume that this is 1, so the constant is a constant term with x power 0. So when you do the differentiation using this rule, 0 multiply the front and you have 0 times 1 times x to the power negative 1, 0 minus 1, but then 0 multiply the whole of this is 0. So whenever you differentiate a constant, you have 0. Okay, then that will give me 0, so I won't write that. But when it comes to the last part, notice that 2 over x is the same as 2x to the negative 1. So we'll apply the differentiation rule on this. Okay, so you multiply negative 1 to the front and you have minus 2, then x, then minus 1 minus 1, you have minus 2. Okay, so again I can go ahead and simplify this using normal algebra. Okay, so it's s squared minus 1 over 2 root of x. Okay, so I want you to know how to go and how to move from this step to that step. If you understand that too, that's cool. Then minus 2 over s squared. All these are from indices. Okay, so this is the final solution. Now let's look at the application parts of the differentiation. You find the coordinate of the point on the curve with equation. So the curve is given by y is the same as f of x and is equal to 2s squared minus 7x plus 1, whose gradient is 5. So at the point where the gradient is 5, how do you find a point of coordinates at that point? Okay, that's what the question is about. So note this: in differentiation, the gradient of a curve or gradient on a curve is the same as the derivative of the function with respect to the independent variable. Here the independent variable is x, okay, and the dependent variable is y. Okay, so the gradient given here is equal to dy dx. That is the idea here. So now the gradient is 5, so but then y is also giving us 2s squared minus 7x plus 1. So I want to differentiate this straight. Dy dx will be equal to 4x minus 7. I know how you can do this because I did that in the first question. Now if I when I have this, then I can equate this solution to the gradient, because I said in differentiation the gradient is equal to the derivative. Okay, at that point, so you have 4x minus 7 is equal to 5. Okay, it should be equal to the gradient, so that you have 4x minus, or 4x is equal to 5 plus 7, and this implies that we have 4x equals 12. Okay, and x will be equal to 3. So if x is equal to 3 at the point of the gradient, then what will be y? Already y has been given us 2x squared minus 7 plus 1. So wherever I see x, I put 3 there. Okay, x is equal to 3. So y will then be equal to 2 into 3 squared minus 7 into 3 plus 1. And when you simplify this, you have y being equal to negative 2. So then the coordinates of the points on the curve with equation y equals, that is given by x is 3 and then y is negative 2. Alright, so this is very straightforward, right? So yeah, that is what we have for today. Alright, stay tuned as I upload different videos on solving different aspects of mathematical problems. Okay, so you'll be able to abreast yourself with so many ways of solving problems. Alright, thank you, and don't forget to subscribe to my channel if you have not subscribed. See you next time.